we'll dive right into our presentation because I know it's a very action-packed day and I don't want to miss out on any of that action as well. But thank you so much to the entire GITS organization for organizing this wonderful conference. And of course, we are living in an era where we are dominated by conversations around AI agents. And even this conference, we have had probably 10 to 15 different sessions around architectural patterns around agentic AI, or even defining what kind of use cases we should build with agents. So just a quick hands, probably if I can understand, how many of you were able to actually get and attend a session related to AI agents? Can we have a raise of hands? So looks like quite a lot of folks. So what I'll do is that in today's session, we are going to be talking about one step next, which is, okay, your company has understood that we want to build an agentic framework and we want to build a use case around agents. How can you productionize it? And also, the most important aspect of when you productionize it, how can we implement best security practices and measures, right? Because we usually talk about adopting a technology, but there are also a lot of different inherent risks and security aspects that need to be taken into consideration. So that's what my session will be all about today. A quick introduction. So I'm Shivay. I'm a developer evangelist at Couchbase, which is a distributed NoSQL database. And I'm also a Docker captain, a CNCF ambassador. And if you wish to connect with me, I'll be at the Couchbase booth. We're also doing a really cool giveaway. So if you want to just quickly scan this QR code and enter to get some special swag, you can get it at the Couchbase booth, which is on booth number 26. So you can scan this and you can come to our booth for some exciting conversations. But let's kind of start right into the dynamic shift that we have seen with AI, right? So, of course, at the end of 2022, we saw the launch of ChatGPT. 2023, we saw a lot of different LLMs, both open source and closed source, coming up. And then 2024 was kind of evolving of these LLMs to become more responsible. They had reasoning capabilities. And we saw the rise of technologies like vector search, a lot of different databases, including Couchbase, adopting vector search for enterprise use cases, and also, of course, retrieval augmented generation. And towards the close of 2024 and, of course, 2025, I think we can safely say that we are living in an era of AI agents. And, of course, there are a lot of different protocols that allow us to define these agents in a very easy manner. Now, whether it is using agentic frameworks or protocols like MCP or A2A by Google, which is the agent-to-agent protocol, which allows you to define these particular agentic frameworks and allow you to adopt it to your existing applications very easily, right? So, of course, the given premise is we are in the era of AI agents. Now, I'll not take too much time about introducing what agents are, because I do understand that some of you might have already attended the sessions, but let's take a quick primer before we dive into more enterprise-focused use cases. So at its core, why, first of all, companies and even individuals are really excited about agents? Because we have truly seen the capability of LLMs as these tools that can look at any type of problem that you give to them, and they're really great at being able to generate either text-based response or even images. But where LLMs do fall short is that they cannot connect directly to your database or to your external API. But that's where agents can actually come into picture, because agents have the capability to do reasoning and solve real-world business problems while still being able to actually connect to your proprietary data or being able to use external APIs that these LLMs were not capable of doing that. And that is why we have seen a very huge rise of interest and POCs being built across the entire industry. In fact, like I spoke to over 500 developers just across 3 days at GITS, and a lot of companies, big companies, small startups are at least building POCs or already releasing agents in production. And just in a nutshell, what agents are. So the goal is to be able to solve a business problem by being able to be autonomous and have reasoning capabilities by using large language models. And the way that they are able to do that is by having all of these rich set of tools that they have access to. And they can interact with the individuals or humans in a natural language, and they can iterate over their tasks that they are performing. So take an example of a simple travel agent where you can ask it to book a flight, you can ask it to plan your flights for you, and it can retrieve data from Google, to understand your requirements and give you a really well-structured library. And with tools like MCP, you can also actually now go ahead and ask it to book the flights for you if you trust it enough. Now, at its core, as I have already mentioned, that how agents work is that they use these tools and prompts to be able to actually carry out tasks for you, while at the same time having a reasoning capability to be able to understand whether the tasks that they're performing are accurate enough or not. More often than not, you might actually not just employ one single agent, but you might have a multi-agent example where there are multiple agents at play and each one of them has been designated a given task. And in fact, you can also let one agent understand that whether another agent is doing its job correctly or not, and have communication between the different agents to make a much more strong environment. At the same time, at its core, you also need something like agent memory and logging. Because if you're specifically using agents for production applications, you want to ensure that at every step, you're able to understand what was the output given by the agent. Because if you're deploying it in production scenarios, you don't want it to do some task that you didn't expect or give out some wrong results. So we need to also ensure that we can maintain guardrails. We can also have version control of our agents to understand how these agents evolve over time. And for a specific business use case, are they actually performing as we expect them to? So it's really important to ensure that you can have checkpoints, that you can understand that what was the response of the agent at that particular checkpoint and how does it improve over time. So that is why we'll talk more about how can you build more enterprise-focused agentic workflows, right? Now, if you understand a simple LLM, you give a prompt to the LLM, it will do its analysis and it will give you an output. Now, if you talk about an agent really works in a way where you make an LLM call and it will use a set of different tools and it will give you a result. Now, where workflows come into the picture is that what exactly are workflows? Workflows are a set of defined steps that you can perform. Now, of course, workflows are also used outside of agentic applications or even AI applications. So how do we combine the combination of the workflows with agents? And essentially, we talk about agentic workflows. So it's in a nutshell, what an agentic workflow is, that it basically describes this iterative steps that the agent will also take in order to solve a particular business problem. While you can completely run agents on their own, with that approach, it would be more open-ended, where you're giving complete control to the agent to be able to iterate and probably understand the problems and try to solve it if you have enough trust into the agent. But if you want it to fit a particular business use case, you're better off using something like an agent workflow, where you define or you guide the agent with a set of steps that it should follow so that you can then leverage it for particular business workflows. And there are, of course, a lot of different open source frameworks, including something called as Langgraph. So Langgraph is an open source language agnostic framework that is specifically designed for multi-agent orchestration. So some of you probably might have heard of LangChain, which is one of the original open source libraries for being able to build composable GenAI applications. So Langgraph takes one step further and it allows you to build these cycles where you can have either single agent or a multi-agent framework to be able to then very easily put in different agents, run them together, orchestrate the workflow where you're having, let's say, one agent understand the output of another agent, and then it can give its feedback, and you can create these human-in-the-loop kind of feedback loops, which you can then inculcate in your own real-world use case. And here are some of the key components of Langgraph. So, of course, as the word graph comes into picture, you can associate it with the different terminologies that we typically use with graphs. So we have the nodes, which kind of represent the individual agents that are having their own distinct role at play. And these agents might be responsible for booking a travel, or they might be responsible for capturing or fetching data from Google as being like a research agent for the trip that you're trying to plan. And then the edges between these different nodes, they kind of represent that directional connection between these agents. So for example, if you want to set context for one agent, and just a very quick example would be that if you're building a travel agent, right? So your first agent would be the research agent that is quickly doing the the research about the trip that you should make, and then it gives that context to another agent that will now very beautifully tell you a well-structured output plan that you should follow. So this direction flow of the context between the different agents is carried out by using these edges. Now, sometimes you might also have more complex edges, which are more conditional in nature, that kind of also describe the business workflow, that based on the output from one agent, what set of actions your agent should perform, right? And then state is what is basically the state of information that is passed between the different nodes. And this state is essentially just your different agents that are kind of looking at the responses from other agents or responses from the tools that they're using and distributing that entire knowledge amongst the entire enterprise application that you're building with your application. Now, of course, if you look at a typical architecture at a very base level, you'll have a set of LLMs, you'll have the agent loop that has a set of prompts and tools at its disposal, and you're using it with the human who is asking the questions to your agent, and you're getting some responses. And typically, you might also need some separate backends, like a vector database if you're trying to build a semantic agent that has the capability of being able to use vector search or even RAG to be able to find appropriate set of documents or data and then enrich itself with that data to be able to give you a response. But in case of a production-ready application, we might have more than 100 plus different tools or even prompts, right? Because if you have a large enterprise use case, you're not just going to be having one or two different tools. You might have 50, 100 different tools at your disposal. So the volume and the variety of different tools also varies at an enterprise scale. So how do we deal with this kind of a problem, right? Another use case is that you also want to be able to add perhaps some level of authentication, that there might be certain tools that should not be given to certain type of users. Or how do we make more intelligent selection? Just imagine that you're giving a question to the agent and you have 100 different tools. How does the agent actually use the right kind of tool? How can we build in some level of intelligence that it can actually use the appropriate tool and not just use a random tool? So a lot of you might have probably heard of MCPs. MCPs are great, but they also kind of face this similar kind of a problem. Because if you have a large enough enterprise level MCP server, for example, if you're trying to build an MCP server for Kubernetes, then as you might know that Kubernetes is a very, very large project and you have different components of Kubernetes. You want to look at your pod health. You want to look at what is the current cluster that I'm running inside of my Kubernetes environment. Or if you have a multi-cluster environment, what cluster is failing? What are the logs that I'm getting from my current application? So as you might imagine that as the enterprise use cases scale, and so does your use cases or the tools that these MCPs or these agents will use also increases. So you might end up in a situation where your agent or your MCP server might have more than 100 different tools. So you might need a solution where you're able to store these tools and the tool descriptions in probably some sort of a vector database. And based on the input prompt that the user gives, the agent is able to then use this vector search to find the appropriate tool that you might want to use. Another thing that you also want to ensure is that if you're deploying these particular enterprise agents at scale, you want to properly monitor, optimize, and also generate alerts based on the results that are coming from these agents. Because as I mentioned, at its crux, these agents can have they are autonomous, right? So you never know that they might give you some unexpected response. Because at its core, we are using LLMs. And even though you're using structured JSON as input outputs, there is always a chance that you might get some level of unexpected results that do not fit your business use case because of the undeterministic nature of these systems. So you want to actively monitor and optimize these prompts and responses that you're filing in. Now, at its core, Langgraph or even LangChain, while they're great, they don't provide these solutions out of the box that I've just mentioned. So you need to be able to build your own level of architecture that can monitor the responses, that can probably use some sort of an optimized way to be able to handle such large number of tool calling. So that is why my company, we built like this open source framework called as Agent Catalog, which is kind of built on top of Langgraph. And in fact, the idea here is not to sell this particular open source tool, but to kind of tell all of you how your enterprises or your companies can perhaps also build something similar, right? It's more about sharing the architectural patterns that we invent. So this agent catalog, of course, as I mentioned, is built on top of Langgraph, which is an open source framework. And what we do is that we typically just go ahead and set all of these different tools and your prompts into a vector database. And then whenever the user is asking a question, we'll use semantic search to be able to find the relevant set of tools that will be most relevant to your application that you want to solve. And then you'll be able to have this dynamic versioning of the different tools as well, so that you can very easily change between the different set of tools that you are using. And then you can also then store all of the responses inside of your database. At the same time, we also store all of the different logs, and these persist. So at any point in time, if you want to go back, let's say half an hour ago, what was the response from your agent? Just to do some sort of sanity check or quality assurance to ensure that your agents were working well, you can do that very easily, right? So let's take a look at this agent catalog with Langgraph in action. And of course, it's completely open source. You can have a look at the repository, and I'll be sharing the links to all of you. So here in this case, on the right-hand side, and I'll just probably zoom in a bit more for everyone. So what you'll see is that I've built a simple Langgraph-based application, right? I'll talk about the agent catalog in a bit. But if some of you have built agents with Langgraph, it should be fairly straightforward to understand. So by default, we always start by using the Langgraph imports into Python. And then we define the state graph, which will, of course, now incorporate all of the different states, all of the different agents and the different tools that you will register with your Langgraph agent. So in the first, what we do is that we start by defining our structure of our graph. So in this case, we start by adding an edge that will initiate the chatbot in this case. And then we also add some nodes for our agent to use, right? So here I have basically two different type of tools that I'm going to be using. One is a text-based tool that will just simply give you text-based response. And some of these are more binary tools, which are probably like using some sort of an external API call. And I just add these particular tools to my graph. And at the same time, I'm also just adding these edges and some conditional edges that based on certain tools that are going to be conditional in nature. That means that the response might be based on the question that the user is asking, and it can be dynamic based on the situation that your agent is right now. So we go ahead and just compile this entire graph and we run it, right? So of course, that's a simple example of a Langgraph use case. But now let's say that, of course, this particular example is, of course, still very small, where we have only 5 to 6 different tools. What if you had like 100 different tools? So that is where the agent catalog, which is an open source library, again, built on top of Langgraph. So I do a simple import of the agency. And here, in this case, what I do is that I have this provider, right? Where I define my backend database where I'm going to be storing all of my prompts and the different tools that I'm going to be using. And again, just to kind of reiterate, what's going to be happening over here is that if you have, as I mentioned, a lot of different tools and you want to proactively understand what tool will be appropriate and not have the Langgraph to basically iterate over one single tool at a time to identify. If you want to quicken that process, you can leverage semantic search. So we'll go ahead and register all of the different tools that we have defined in our Langgraph, and we will store them inside of the database so that we can then use the semantic caching. And similarly, what you'll see is that in my code base, I have this my app.log. And this is essentially what all of the different logs we are capturing whenever the agent is making any call, or it's giving you a response, it is using a particular tool. We're capturing all of that into this. Right now, for now, it's a log file. But in your enterprise use case, you could also then host this log file with Prometheus or Grafana, and then probably look at the current visualizations. And if your agent fails at somewhere, you could probably also create automated alerts with your framework. So we are just capturing all of this with the help of this framework. So you can see that it's executing the query, and you can very easily then understand what's the response like and probably improve the agent if you feel that somewhere your agent is actually lacking. So that's a quick overview of what we are basically doing with this Langgraph. It's with the agent catalog. It's nothing but just providing external capability to improve the overall functionality of your Langgraph agent. And if you have multiple agents, you can also use a multi-agent framework. And just to quite quickly give you like a demo of this particular application. So here is like the front end, like with the Streamlit application. So what I did was that I took a bunch of songs and I kept them into my database, and I built a simple agent where I have all these different tools where I can search a particular song on the basis of a particular tool. So for example, if I ask it, tell me about the song Imagine. So what it's showing is that the first response is just a pure OpenAI response, and the next response is coming from the agent that we are running. So of course, in this case, it will take some time. Of course, production, always we see some level of difficulties. Let's try to run this again. So I'll ask it the same question as before, and we'll just wait for the application to load. But what you'll also see is that as I'll work with this particular application, we'll see that why pure LLMs are not good enough. Because if you want to perform certain tasks, like, for example, if you want the LLM to play a song, of course, the LLM will not be able to just play a song because it is still just limited to generating text. So for example, here in this case, I got a pure response from the LLM. But now if I also want to see a response such as play the song, so the agent will, of course, work over there. So if I say that now play the Imagine song, of course, just a simple OpenAI would not be able to play a song. But of course, if you have an agent with you, the agent can have a Spotify API tool call, and it can actually go ahead and play that song, right? Now, if you also want to see like a visualization of how the graph actually looks like, in this case, the Langgraph that we have. So we can also look at the visualization of our Langgraph itself. So here you can see that this is the Langgraph agent that we have deployed. In this case, we have one single agent, which is the chatbot, and it has access to these two different types of tools categories. And we are running this, and you just saw that one set of tools is just a text-based, and other one is using external tools to be able to make a more dynamic agent. So that is a quick premise into what I wanted to kind of convey with, agent workflows, right? Where you define a set of tasks that the agent can basically perform to make it much more inclined with a business use case. But what about security, right? So that's the next part that I would like to quickly also talk about. Because if enterprises are now trying to inculcate these agents into their applications at a production scale, security is a really important aspect that all of us should consider. So whether you're building a RAG application or an agent application, there are some really important security implications that one needs to consider. So we'll also have seen probably this at some scale that there have been multiple security incidents involving large language models. Whether you talk about the DeepSeek controversy or even, sometimes OpenAI probably giving out responses that are proprietary data of some companies, we have seen these type of security vulnerabilities. And these will even grow further as we dive deeper into more enterprise-focused agent workflows. So what to do about that? So here is like a basic proposal of how you can basically implement zero trust security in your LLM application. So this kind of starts from an external user which makes a request. And at the start itself, you can basically implement something like an attribute-based access control, where based on the role of the user, based on whether they have access to certain parts of the application, only then they will be able to actually access the application itself. Now, if they have that access, this is where you would want to, of course, still implement your traditional access controls or have proper API keys, which is, of course, something that is pretty much, something that we always also involve in our traditional applications. But where we kind of now differentiate when it comes to differentiating between traditional applications and agentic applications is the fact that these LLMs are non-deterministic in nature, and there are techniques such as prompt injection, or perhaps if you don't have proper control, these LLMs or some sort of hacker could basically get access to your proprietary data by being able to probably use some sort of a prompt that can go beyond the guardrails and get some proprietary data that, of course, is a huge security lapse, right? So this is where we can implement best security practices when it comes to implementing zero trust security. And if you're not already aware of OWASP, so OWASP is a foundation that usually gives you top 10 API security implementations that every organization should have. So they also release this OWASP for LLM applications. So that means that every single enterprise use case application should have all of these different security risks involved with LLMs. Now, whether it's prompt injection or improper output handling of your LLMs, or sometimes you might actually have proprietary information or your personal identifiable information being leaked by using these agents applications. So every enterprise should have these in mind when you're building your agent applications in production. And the idea is that every single prompt, every model, and every output should be verified and logged and monitored actively. Now, of course, we are running a bit out of time. I wanted to kind of dive deeper into each one of these practices, but this is kind of an architecture of a generative AI, Gen AI application that uses this particular security, zero trust security at the helm. So what you'll see is at the top, we are using a typical API gateway level of security with use of proper API keys. And we are also using rate limitation. We are going to be having some level of security and governance. But where it kind of shines specifically for LLM applications is guardrails. Because you want the LLM to not give some response that is probably not safe for work, or probably something that is not safe for that particular use case. So that is where you can implement guardrails. And there are a bunch of different open source frameworks that you can leverage to add these guardrails for your LLMs or your agents. And at the same time, you might also want to have hallucinations being detected, because you don't want the LLMs to just generate some response that doesn't make sense at all. And this, you want it to always be very much focused towards giving you real results and not just make up some results. At the same time, there's an entire use case of companies who want to do private deployment of LLMs. They don't want to rely on OpenAI, because OpenAI, you never know that they might be using your LLMs, your responses or your data for training of their models. So we want to be able to host these models privately, right? And that's one of the biggest security risks that we want to take into account. So that is why a lot of these are also implemented in our company that we basically have it at production, which we call as an Capella AI services, where you're able to self-host your LLMs with the help of open source tools like VLLM right next to your database. So in this case, your data is secure, there's lower latency. So if you're interested to have a chat regarding this, please do come talk to us at our booth. We'll be more than happy to share more about the behind the scenes architecture on how we implement it, so that, for example, if your enterprise application requires you to deploy an LLM, how do you deploy that efficiently? Because most SRE teams might not have proper understanding of how to deploy agents or how to deploy these LLMs at scale. So we'll be more than happy to share some of these resources of how we implemented it at scale. But with that in mind, I'll just conclude with some final slides. These are the QR code for my presentation. So if you're interested to go back and have a look, you can scan this QR code. And I'll just quickly share a couple of other QR codes in the end. So, of course, as I mentioned previously, do check out our booth. We are running some cool contests as well. And you can win some swag as well if you scan this QR code. And of course, if you have any questions about my presentation, I'll be at our booth and I'll be more than happy to answer any questions regarding running agents at production, running, security practices. And of course, if you are interested to join our Discord community or try out a free trial, you can also scan these QR codes. But I know we are probably about out of time. With that, I'll conclude my talk. Thank you so much. And it was a lovely pleasure interacting with all of you.